on now to an expert's view. Please have a seat as we're about to start. We will talk about a very hot topic, a topic that is on the lips of everyone, a topic that, to be honest, excites me and scares me because I don't know if one day I will still be presenting and moderating. And it's all about generative artificial intelligence on infrastructure and energy assets class. With our experts today, let me introduce them very briefly. We have the pleasure to have with us Eric Benoit, your technology research specialist at Natixis CIB, and Pascal Soleidaini, you are regional head of infrastructure and energy finance UK and Nordics, also at Natixis CIB. Well, the floor is yours.
Thank you, Christina. So, indeed, generative AI is at the core of the transformation of our world. So we couldn't miss the opportunity of the Infra Day to talk about it. We hear about generative AI pretty much every day. And last week, for instance, the French government announced the implementation of a test to get AI supporting our civil servants. The first ask I have for Eric is to remind us about the basics. So Eric, what is generative AI?
Generative AI is actually a focused field of AI research since about 2014, even though, Pascal, it has earlier incarnation. I think you might remember in the 1960s a chatbot called ELIZA, developed by MIT professor Joseph Weizenbaum. But whereas ELIZA was actually relying on some kind of very smartly scripted set of rules to give the impression that the system was intelligent, ChatGPT, Bard, and the likes are relying on very different kind of algorithm, namely transformer algorithm, which have been developed in 2017 by Google researchers. And those transformer algorithms were developed to solve a particular problem called transduction problem, which is the transformation of one input sequence into an output sequence, such as in language translation or extension, a number of things involving pattern recognition and anomaly detection and so on and so forth. Now, these transformer models are pretty specific in their architecture. They tend to be, first of all, very, very big models, a very deep neural network with a lot of parameters, hundreds of billions of them. And as we shall see, this has big implications in terms of infrastructure. Then they tend to outperform as well their predecessor models, thanks to a mechanism called self-attention mechanism, which allows them to sort of keep track of all the subtle relationship between words inside the input sequence, even though those words may be actually quite far apart. And this is how they manage to extract context, extract meaning, and this is why they are so powerful and useful potentially to a wide range of activity sectors.
Thank you, Eric. So now, moving to a more macro approach, could you tell us what would be the expected impact of the generative AI on the economy more globally?
Well, I mean, if you look at every sector in the economy, from finance to healthcare to education, legal, industry, every single sector has done their homework and they've already identified their fair share of opportunities using the technology. Things like building chatbots to enhance customer experience, or automating processes, or marketing, advertising. I mean, the possibilities are really endless, and there's certainly a lot of potential for this technology to revolutionize part of the economy. That said, I don't think the whole thing will happen instantaneously. There are sectors that will adopt the technology faster than others. But let's say, that all the problems that we've seen over the past few months, I'm thinking about hallucination problems and kind of things, let's say that these things get sorted and resolved within 2 to 3 years, then I guess from a macroeconomic perspective, the real question is, will we actually see the productivity gains that everybody's talking about actually materialize over a long period of time? If you look at the numbers in the street right now, some of them are actually quite impressive. I think McKinsey, I don't know if we have any people from McKinsey here, but McKinsey came in June with a big report. In the best case scenario, they could see something like 3.3% productivity growth every year up until 2040, which to me is insanely optimistic, insanely. Others are perhaps more realistic, between 50 basis points and 100 basis points, still a big number. You know, if you look at what's happened in the past with something like the internet, actually the internet has disappointed in terms of productivity gains. So the question is, will AI actually be any different? And if you analyze productivity as some kind of ratio between your economic output and your economic input, and you look at the output part of the equation, for sure, it's a reasonable assumption to think that AI is going to create new products, new revenues, and you know, we don't know what these revenues are going to be, but it's a fair assumption to make. If you look now at the inputs, then we're talking about reducing cost, really, which means automating more and, of course, destroying human labor. I think Goldman Sachs came up with a huge number of 300 million jobs potentially at risk of being replaced by artificial intelligence over the next decade, which is enormous. And so the whole thing will be met with friction. It will be made with more regulation. It will not happen over time. It will be important, but we can't overstate as well the impact because of all those reasons.
Thank you, Eric. So then let's move to the key question of our expert view, which is in a more micro view, what would be the impacts of the generative AI development on specifically the infra and energy asset class? In particular, shall we expect more data centers, and there were discussions before the previous panel, more energy consumption related to these data centers, growth, or more efficiency as well? So big question mark.
Well, if you go back to what I was saying earlier about transformers models, the thing about these models is that the bigger they are, the better they work. Okay, so they have hundreds of billions of parameters, and therefore they require huge compute power. CPUs in their hundreds of thousands, but also because they work quite well in parallel, they require GPU chips as well in enormous numbers. Then the self-attention mechanism that I was discussing as well a few minutes ago requires a lot of memory capacities. In fact, the memory requirements are quadratic with the size of the input in the model. And then if you're using the technology for some kind of real-time application, then you're going to need as well some very large bandwidth capacity. So you see that very quickly we are going into a supercomputing problem here. And supercomputers tend to be obviously based in the cloud as opposed to in your living room or in your office. Although your living room is quite big, but if you take an example like Microsoft, when they built the infrastructure for OpenAI's GPT-3 model, they assembled something like 285,000 CPUs. They added 10,000 NVIDIA GPUs to this. They built basically the 5th most powerful computer in the world at that time in 2020. And all of that was in the cloud. So we think artificial intelligence is indeed going to drive big demand for this kind of infrastructure, either hyperscale data centers, so the big ones, but also smaller, more compact infrastructure closer to the user at the periphery of the network, like edge computing type of data centers. Today, this whole market is roughly worth about 250 billion in 2023. We see it going to something like 7.5%, 8% a year until 2030. Why not more? Well, because there are a few challenges on the way, obviously. The first and biggest one being access to energy infrastructure. That in tier 1 location like London, like Paris, it's actually becoming quite difficult to find the 40, 50, 80, 100 megawatts of electrical power that are needed for these kind of data centers. Then they also need, obviously, renewable energy, as was discussed in the previous in a previous roundtable. That's not, necessarily very easy to find those 20-year contracts on solar, wind energy, and then you have the problem of intermittence. You have the problem of storage, which is always difficult, and the regulator is becoming worried as well, starting to implement a lot of constraint, and I think that's going to be a recurring theme as well over the next few months. So it looks like AI's future, and I would say data centers' futures goes through greater energy efficiency. I believe that actually in 5 years from now, we'll be in a much, much better efficiency level than we are today. There are actually many technological paths that are currently being explored by the big guys in the industry. Cooling technology is one aspect. 40% of the data center tends to be linked to cooling technology, so immersion cooling will make a big difference here, I think. We need to look into this more closely. Then microchips architecture, I think, is really essential as well. We're going to see more of those 3D microchips with, the memory block coming on top of the compute block, or sometimes the compute block going inside the memory block, to sort of limit the amount of data transfers between CPU, GPU, and memory block, and making the whole thing a lot more energy efficient. We'll use lasers instead of electronic circuits to transfer data. That's going to make a huge difference. And finally, to conclude, AI models, are going to improve as well. We won't be needing those billions of parameters anymore to produce the same sort of results. These models will be using different, optimized mathematical framework with different levels of precision. And so I'm definitely very optimistic that the whole thing can become more sustainable as we move forward.
Thank you, Eric. So finally, as a conclusion, we have recorded the interview of Dominic Ward, the CEO of Verne Global, which is a data center operator that we financed this year, and it deals with AI players. So the question for Dominic was the same. What is the impact of generative AI development on your business? And so let's listen what Dominic answered to this question.
Verne Global is a data center operator that delivers sustainable data center solutions that enable organizations to cost effectively scale their digital infrastructure whilst reducing their environmental impact. And we focused for well over a decade on high intensity, high performance, and cost-effective compute infrastructure, whilst at the same time ensuring that our customers can reduce their carbon footprint enormously. And so we work with companies in the financial sector running huge research models. We work with customers in the manufacturing sector running enormous computationally intensive workflows for computer-aided design and computational fluid dynamics. We work with customers in the pharmaceutical industry trying to find protein therapeutics that can be applied for the pharmaceutical industry. All of these and many others use massive computationally intensive applications and workflows. And at the heart of that type of compute is increasingly what we now refer to as artificial intelligence. And AI in the data center, whether it be called machine learning or deep learning, most of it is driven by GPUs and parallel computing. And that is very much a trend that has been going on for a number of years. We've seen the growth in GPU processing over the course of the last several years rise from something in the order of 100,000 GPUs about 3 years ago, manufactured and put into data centers. And it's forecast that in about 3 years' time, 2026, that will be more like 725,000 GPU processors in data centers annually. So that's 7 times growth over a 6-year period. And then if you look at the expenditure going on sitting in data centers around AI, this is a market that is exploding, where last year it's estimated by UBS that around $28 billion was invested in AI digital infrastructure and data center infrastructure, but that's expected to rise to 300 billion, 10 times the amount by 2028. And what we're seeing is huge density increase because the parallel processing used for AI is enormous. And most data centers are not ready for this. Verne Global is an NVIDIA preferred partner, and we've been a partner of NVIDIA's for such a long time because of the density that we're able to provide by being focused on Nordic locations where we source renewable and efficient energy, providing our customers with more efficiency but sustainable energy to drive that enormous growth in AI digital infrastructure. And this is a trend that we're going to see for many years to come. There was a recent forecast by Digital Bridge that the total footprint globally of the public cloud is around 13.8 gigawatts today. That's all of the large public cloud operators. And yet they're forecasting that within 5 years' time, artificial intelligence compute will require something like 38 gigawatts of compute. So this is enormous growth that is going to have to sit in an efficient, sustainable location. And there are only so many places on the planet that can actually even provide that type of density and power. So we're very excited about the growth in the market that is coming, and Verne Global is very well placed to take advantage of it.
Well, thank you very much. Great applause. Thank you. Very...